Hello, everyone, and welcome to another episode of Observable Flutter. I'm your host, Craig Labenz, and today I'm excited to have a first-time guest on the show. We're going to talk about image filters, as the card says. We've all used image filters in various social media apps, obviously like Instagram. I think they became very popular for having extremely high quality image filters back very early in the social media photo sharing era. And we're, I think, going to go under the hood a little bit today and learn more about image filters. So without any further ado, let's get ready to get into it. First, as a reminder, folks, this is the Flutter community. So do want to remain fully respectful of each other and all the good things. But I know that we're all up to that challenge. Okay. So today's guest is, wait, let me try to remember here. Raouf Rahiche, I believe I said that right. Raouf, please, you're in just a second going to have an opportunity to correct me if I misremembered what you told me 10 minutes ago. Raouf is a Flutter GDE and just a total expert, an absolute delight, great public speaker. And recently, as we're all about to learn, is a self-taught budding expert in all things image filters. So, Raouf, welcome to Observable Flutter. Would you like to say a little bit more to introduce yourself?
Hello, Craig. Thank you for having me. And you got the name absolutely correct. I'm glad to be here, and I'm really happy to share all the stuff that interests me with the audience of the Flutter channel. Yeah, as you mentioned, I wouldn't call myself expert in this stuff, but I'm expert at least in what I have done in so far. I'm not sure about the things that I haven't done. But more importantly, I have been doing Flutter for the last 8 years, since early 2018, and stuff related to image filters. I got deep into it barely in the past 3 years, but I have been doing it quite probably every single weekend. So I have some cool demos to share with you today.
All right, great. And I'm getting a helpful correction from the peanut gallery. More emphasis on Raouf. Is that better? Raouf?
Yeah, to me, I'm at this point where I'm like, whatever sounds correct is really correct to me. I'm just I'm just happy that it's actually pronounced correctly.
All right. Well, hey, we're gonna do my best to get it correct. Sai, you must have missed by just a second. Image filters today. All the excitement that I would say Instagram popularized. Maybe it was popular before Instagram, but I think that's when most people got their hands on the power of image filters. So, Raouf, how did you get? What attracted you to image filters? How did you get into this?
Oh, actually, the story has an issue starter for it. It does not start from nothing, but actually an issue that I created back in 2021. There was a new Android version where they had a new overscroll effect, and that overscroll effect was kind of really cool because for the longest time Android had a really weird glow effect at the top, which is, I'm not sure if you all remember it or not because it's now already really old, but there was this glow thing at the top when you're scrolling at the edge. But then you go to iOS, they have a really, really nice stretching effect, which goes beyond the effect. But then Android team has decided to finally take that away and make something even better. And the new version, once I saw it, I was like, we need to get this on Flutter right away. I created the issue probably on the same day of the announcement when I saw it in Google I/O being announced. And I obviously, being so naive, I thought it's like, oh yeah, this is a very simple implementation. Just add some padding here and use this transform here, and that's how you're gonna get the stretch effect. But that wasn't true. I've got the reply from Katie from the Flutter team, and she replied that they have been looking into it, but the thing is it's not uniform, so it needs to be applied on different values at different levels. So the more you're closer to the edge or the anchor point, the stretch the stretch effects differentiate from there, so it doesn't look like it's stretching by the same value across all the view. So from there, she mentioned that we will need to be using shaders for that, and the conversation goes on deeply after that, from people noticing how the value is not the same based on how far do you scroll. The issue is still open, but they have already, like, the current Flutter version already actually implements this behavior, so they have actually fixed it, but they are not using a custom shader for that. They are using just a transform widget, which does the thing, but again, if they wanted to make it pixel perfect with the Android implementation, they will need to use a fragment shader. That's why the issue has been rebranded to be called re-implemented using a custom shader. And I think this will hopefully happen at some point soon. But that was my introduction to it. That was the first time I have heard of it. But then I started to create a lot of samples around shaders just to learn them. And that's basically how I got into the art of shaders, or which are also another way of saying, less technically, image filters. Those are what I'm talking about here when I refer to shaders as well.
Gotcha. Okay. So now a lot of people have filed issues about things. So that's what I'm hearing in this story so far. You identified, a thing, filed an issue. There's been a conversation here, but there's got to be more to the story, because now here you are presenting and talking and teaching all of us, myself included, about image filters, maybe via shaders. We'll all find out over the next hour or so. So what did you do after you filed this issue? I mean, you must have dug in yourself.
Well, yeah, for sure. Well, I tried to learn about how they work or what they are, but then I like, by just looking at the places where they are used, I saw some pretty amazing visual effects that when I saw them, I was like, well, these cannot be implemented using basic building blocks, and they can only be built with shaders. So that's when I actually started to try to replicate those visual effects, try to get them to work with like starting from the super basic ones to some complicated ones, and I'm going to show multiple of them just right now after this. But the thing that I did literally after creating the issue was just look at the design doc that was mentioned here, and learned a little bit more about the concept of shaders, but I did not get my hands dirty with writing one or trying to integrate one in a real application until like a couple of other examples that were mentioned in the issue here. The issue it has a lot of people in the conversation, but they mention related issues where they also need the use of shaders. And I actually implemented one of the effects that was mentioned here. So one of the effects, the issue is pretty big, but I think I better go off with let me see if I can find it here quickly, but if not, I'll just go to show the demos. So yeah, that was basically what I did after finishing creating the issue and getting the feedback.
Nice. Yeah, I find that inspiring myself. It's so easy to feel like kind of going below pure Dart code is like this really firm boundary, the crossing of which is, not available to like normal developers like us. But you of course can, if the given topic is interesting enough to you. So yeah, you did, and that's cool. So what are we looking at here?
Yeah, so I created, as I said, hundreds of them, like at least not from scratch, but trying to get them from shader toy into something practical. But I have picked up some of the useful ones that I saw were really interesting and useful for the discussion for today, since all of them are image filters as well. But let's start with the first one. Actually, the first one is a transition from last week show with Hinan, where the last question was from someone asking you about creating a ripple effect. Well, it is also an image filter as well. So this filter was a filter that I ported to GLSL, which is the shading language that is supported by Flutter. The same day it was released by Apple, WWDC 2024, they created this effect. The iOS community went totally happy about it. So they were creating a lot of videos saying, wow, this is the best. You can do this everywhere. But obviously they posted the code, the sample, they just did it in Metal language, which is the shading language that is used on
Apple
iOS,
uses, yeah.
native iOS development. So I take a look at the code. Obviously, I don't know how to write Metal, but somehow, because this is super, super low level, it's basically just math. And I don't need to know the syntax. I can read math, so I can take the math from the Metal code and put it into GLSL. And the result was there like pretty much on the same day. So I was pretty happy about it. This is an image filter, and it falls under the kind that is called distortion filters, where obviously there are multiple other types. Like you have the blur one, which are the most common ones. You have an image, you have an input image, and the output image is just less noisy. You have the color correction ones, which plays with the luminance and brightness of each color and try to adjust it to look a little bit correct to the eye if the picture was taken somehow in a really wrong way. But then there are the other image filters that you have mentioned at the beginning, which are the Instagram ones. They are called like creative image filters, which obviously do not they are not like inspired by nature, but they are inspired by things we already love and have seen before. For example, the grayscale effect, which takes an image that is colored and make it grayscaled. That obviously is interesting and creative to us just because it looks old. So you take a picture and you add the gray out image effect on it, and it will look old. So they are creative because they are not inspired by nature per se, but they are inspired by the things that we always see and love. So those are some of the kinds, and this is just another kind. You have an image, this is the initial image, and the final image is it differentiate at different points of time, but this is also just an image filter being applied at multiple frames. Another one I would like to show is one that was one of the first ones that I have made. It was an iOS animation where when you put two phones together, you want to share the contacts. They made a pretty incredible animation. Obviously, the thing that was really good or really interesting about it was the animation itself, not the idea of sharing contact, because that was possible in an Android 10 years ago. People were using NFC to change the contacts before, but the thing that Apple did really nice here was the animation of when that happens. So this is just a simulation of that, how that happens. I just literally used two device frames in order to make that to make the animation more realistic and looks even cooler, but the animation is just being applied on top of the entire application. So if I try to do it again, you will see that it has an impact place, and then it does a little bit of blurring at the bottom, and then there is a wave. So it's a combination of blurring and then that nice little ripple effect, but we end up with a pretty good result. I wouldn't say this is exactly looking like the iOS one, but it answered my question
Pretty
of
close,
how would you
yeah.
achieve such a thing.
Yeah. So one thing I want to pause here real quick. If you go back to that, and I loved a line that you had a second ago. You said, you might not know Metal that well, but it's mostly math, and you can read math and
Yes.
translate it to GLSL. And I just thought, I can read math is a fun sentence that I've never heard anyone say before.
Yeah,
now,
I mean, I actually, it happened. Probably there is one thing behind each of these. One, like the ripple effect was taken from a Metal. Like I did not write the entire code for the shader from scratch. That will take someone who knows math, not think it's easy to read. That needs someone who's a level above that. Actually, spend a lot of time with it. But for me, it's just because obviously math operators, you can tell how easy it is. Yeah, I think that Randall puts it really nice. I can read some math. I can just write it. Like to come up with an idea and write the effect for it. there is some genius behind that, especially how optimized it is. But yeah, this was a metal shader. The iOS name drop was, I think, it was a Skia. Yeah, this was a Skia. Someone. No, this was actually metal as well, 100%. This was a metal. The iOS name drop one was metal because they made this effect there. The RGB glitch,
So
for
did
example.
they the iOS name drop one? Did they also release some shader code for that, or did someone
Yeah,
else take a
they
swing
released the
at it?
shader code for the metal one. Yeah,
I see.
so
Okay.
for both of these. Um,
Are they open source typically in that way? Like, what's the
well,
so?
the licensing is MIT for all of these, for sure, for
Hmm,
all of these shaders. But I see you're going there because like there is a very, very tricky thing with licensing for shaders compared to other form of software. I think they're somehow very strict about, like, you will probably go to places where people share the code source for some
yeah,
sort of
like Shader
shaders,
Toy, yeah.
and they will have a license above each function that they haven't created. Is because, as I said,
Mm.
like, sometimes you can end up lucky being creating that magical function, not just being completely by logical choice.
Yeah, I was um I just honestly didn't know that Apple had ever released a
Oh,
shader
no, it was not
before.
Apple. No, no. So Apple actually released the shader for the ripple effect. So they actually open sourced this one. It was like
Okay.
in the documentation, they put the full source code for this from WWDC. So this
Uh-huh.
one was from Apple. This one was from the community. The iOS name drop was from the community. Someone open sourced
I
it.
see.
Yeah.
Okay. All right. All right. That makes more sense. I'm gonna say, man,
Yeah.
I would have thought they would have just kept that buttoned up and expose it in SwiftUI, but not let anyone see how it's done. Okay. Anyway,
Yeah.
so on to RGB glitch, maybe.
We will be saying a lot about that bit where Apple doesn't share the code, because we'll have one specific scenario where it was really annoying. There was actually a good story about it. But the RGB glitch, I mean, I had so many other effects that are even better, but I did the RGB glitch because when I did it, it went viral, and it was like the people were half. Some of them were like, wow, this is really good, this is nice effect, I will use it. The other half was like, it looks glitchy, and I'm like, well, yes, that's the purpose, it should be glitchy. But yeah, I'm not sure, have you seen them, the Spider-Man, and not the way No Way Home, is this, yeah, Into the
I think I've seen
Spider-Verse.
half of it.
Yeah, but they had this effect where obviously when you
Yeah.
transition
It's
between one
like,
place to the other, it's like boop, boop, right? So obviously, I wouldn't have created that in any other context apart from this one, which is like you're trying to show the movie and then you just go into it, and it
right.
takes it makes it glitchy. It
Right.
looks glitchy, so it's scary in the theme of Halloween. It's a bit scary, but
Ooh.
it's it does the job, which is just to have a very specific visual effect for the movie. This one was taken from Shader Toy and converted to work straight away with Flutter. So all of these, as I said, not written 100% by me. Um, the next one was the one I think with the most practicality. This one I have seen people use it in their apps, and people
Mm,
letting me know that it's actually probably the most useful one that they have used, which is the page curl one. It's also implemented in an app called Review. They are like the masters of like creating visual effects in applications. But here, as you can see, I'm a big fan of Christopher Nolan movies, but I'm also pretty much in love with the effect, this one, because it looks super realistic. And this one was created by React Native people, and they
okay.
created it in Skia shading language. And again, I'm trying to get back to this point, which is that uh, because shading languages are obviously somehow different, but at the same time, they are so low level that you cannot go more low level than just pure math. So it is
Hmm.
super easy just to get the the code from their side and work it into any other shading language. Obviously, there were multiple issues of trying to get it to work exactly the same, but I think realistically speaking, this is the most realistic delete effect that I have seen, and it does even have sound. If you want to try the web version of it, I have hosted it on my GitHub as well, but it has like a stitching effect. It's like you're trying to rip off something from your hand. It's like, it feels like you're really trying hard to remove an item from the list. So you better not remove it. Be sure to before you remove it. But yeah, those were the examples I wanted to showcase here.
There's a great question in the chat. These shaders, the pure math that you've been porting either from Metal or whatever, are they available somewhere?
Well, this entire session that I'm about to show right now, I just literally pushed this this morning here. So like all of these demos, I just pushed them an hour ago. So you see, I've been doing this at the last minute. But yeah, all of these that I'm showing here are like this application. As you can see, the debug banner here. What I'm presenting here today is just a Flutter app. So all of these are available there. You obviously, as I said, the thing about these is that you want to make sure you read the code. Some of them, I mean, obviously I choose only the ones that were like MIT licensed, but I have too many other shaders like in my GitHub repo. Some of them are like use it but not commercially. So the licensing should be very important for you to read. It will not be in the repo, but it will be inside the shader itself. But yeah, for example, the review page curl one is like hosted here, and the live version of it is here. Maybe we can even hear the sound. It's using Wasm, so I hope it's gonna be performing really well, and it does. Yep. Can you hear it?
I can't, but that is probably a Mac OS thing where the no system audio is going through the live stream.
Well, they can try it on if they go there. But yeah, whatever I'm showing here today, the code is available out there.
Cool. And then another great question, Sai asks, are the shaders platform agnostic? And
well, to us they are. To us, as we are writing the code of shaders, they are, and that is the promise of whoever is doing behind the scene the work to translate them into the languages that are working specifically. Like for example, on iOS, they have a different architecture for the GPU than to Android, and Flutter supports a really long list of devices. So for us, they are agnostic. So whichever, like you have seen, it was working really nicely on a macOS application, and it was working very nicely on the web as well. So I guess for us, we have to think that they are 100% agnostic, and we shouldn't think too much about the details, because that will be the job of multiple layers of the Flutter engine converting that code either to Skia shading language or to the host platform shading language, or going to the web. I think is called WebGL as well. But I will say for us, it's agnostic. For them, it's not. Just to give them the credit that it's not actually agnostic just by default.
Yeah. Okay. All right. So you have more.
No, this is to do. We'll do it later if we get the time. That's why it's to do, right?
All right.
But now that I have shown you like what you can do, like I hope that it actually inspired you about like these custom shaders to create image filters. I want to go back to the basics. So hopefully you're hooked in. But now I'm just gonna go to the basics. What are available by Flutter, like without using custom shaders, without writing the code for it or anything. Just what are the basic image filters. So here I have prepared this playground, has multiple images. All of these images are chosen just in order, like they have different color and they have some transparency and so on. But here I wanted to do this very basic example because I watched the very first episode of Flutter Observable, and you said that it is like you can read the sample code, right? But it is very hard to absorb the amount of information that is at least in the documentation. For example, they say this is what's happening, this is why you don't do it, or this is why you do it. But in other words, when someone is writing the documentation, they have to abstract a ton amount of knowledge into a specific word, because they want to be as abstract as possible. They will not be like describing the thing multiple times. So it is very hard to absorb. And I found that very much the same with image filters. Whenever I mention image filters, the only image filter that anyone will recognize is a blur effect. But Flutter, obviously, by default, gives us access to much more than that. So we'll start by the most basic one, which is the blur. You get the blur. It gives you possibility of changing the sigma, which is either on the horizontal or vertical axis. So if we do it on the x-axis, as you can see, it's blurring, but only on a directional level, which is on the x-axis. You can do it on the y-axis to see the difference, or you can do it at both, which is the most common use case for these filters, because you wanna produce noise, you wanna take out noise and produce images that are harder to read with less details. This is very easy to understand. But the thing that I really get interested in is the tile mode, because with them you can produce. I'm not sure if you have seen a lot of these questions, but it was like about bleeding edges with blurs, issues where you have, for example, the blur is not soft enough at the edges, or it's, for example, flickering when you are scrolling, the blur is flickering. That has something to do one way or another with the tile mode, because the tile mode says, here we are blurring, and blurring is a non-local filter, which means it's not relying only on the pixel itself, it's relying on the neighboring pixels. So
Right, it has to
neighboring
sample
pixel,
a certain radius. Yeah.
yeah, so when we say an edge case, this is literally the meaning of it. We are here at the edge, we are at the top edge, 0.0. What are the
Right.
neighboring
You're talking about
pixels?
your cursor is on the 0, 0 pixel. That's what you're talking about for the edge case.
Yeah, it is. That's the edge case. Yeah, it's here at the 0, 0 pixel. We know the neighbors from one side, and we know we know the other one from the other side, but we don't know from the top or from the left, right?
Yeah. Can you define the word sigma real quick?
Well, sigma is a mathematical word. It's called the standard deviation, which is I think the best way to explain it is to remember that there is like the curve is like the
A normal bell curve.
yeah, the bell curve, which is also called the Gaussian or the normal distribution
Mhm.
curve. Sigma is what's beneath it. But for us, sigma is just the easiest way to understand is that the more sigma you have, the more blurriness you have. It's like this is the most basic form. But why the naming is interesting is because sigma is the mathematical the description of it, but what we have, for example, in tools such as Figma or any other design tools, they do not use the word sigma. They are designed for designers. Designers, they know blur radius, so they give them blur radius. So you go to Figma, you create it with a blur radius, you go to Flutter, you're like, okay, what do I put as the blur radius? So the blur radius is 100, right, in Figma. You're like, okay, I'm going to put my sigma
What's the
at 100.
equivalent in Flutter?
Yeah, and that is the catch. That's really why I wanted to do the basics here, because the sigma obviously is definitely not a one-to-one with the radius, 100% not. There is a formula that converts the sigma into a blur radius. It is out there in the documentation in Flutter and also in the code base for it, but it's not a one-to-one, and it does not increment in a linear way. But the thing that you have to understand is that sigma is not equal to blur radius. It has to go through a formula to translate a sigma to a blur radius. But the practical thing to take away from here is that 100 in blur radius is going to be around 60, 70 in sigma, or even less. So one more thing about performance here is that the sigma is not like opacity. When if you put 0.1 opacity and 0.9, it's the same, it's constant time. Here with the blur, if you put 1 for sigma, it's totally different from 100. So the difference from 100 to 60 is pretty huge in terms of the performance. And that is why after a certain sigma, like for example here, I stopped the sigma at 20, but the sigma in Flutter obviously goes beyond that. But there is a certain level where it stops. I think it's 255 or 250, some sort of a number there. But they actually hard code the number at certain point, because obviously you will have too much blurriness. You will not be able to tell what's the original image and what is not. So yeah, sigma is a mathematical definition for the standard deviation, which is in the, which obviously in practical ways is definitely not blur radius. If you have a large blur radius, just don't take that number and put it as the sigma is the takeaway from here. I hope that answers it, but I will not be able to give a proper definition of sigma mathematically myself, sadly.
Yeah, it's okay. We don't need the proof. And there's been a lot of questions about, I'm scrolling up to see if I can find them again, but broadly, folks are aware of and asking about the performance stuff here. And you gestured at that a second ago when you mentioned that for opacity, any number that you put in takes the same amount of time to compute. You said that was constant time. So right, if you put 0.1 or 0.9, either of those things will activate the fact that the alpha value of that pixel color is lower. And thus at the compositing phase, if there's a layer below that pixel, then its color has to be factored in. And it doesn't matter what opacity value you put, all of those operations take the same amount of time, because multiplying a number by, multiplying two numbers and then like a parenthesis or something between 0 and 1 is the same amount of effort, regardless of what that 0 to 1 value is. But then you said right here, this is not the case, because this higher sigma value takes longer because it's sampling more surrounding pixels. Can you talk a little bit about that for anyone who's unclear about the nature of how the performance hit can come in? I think people have heard and know that, like, oh, blur effects are expensive.
Yeah.
And maybe everyone does kind of understand why, but I think a refresher would be good.
Yeah. I mean, yes, they are expensive, and it's not that it has something to do with Flutter. It's like it's the same across all, like it's algorithmically speaking very slow. And obviously there are multiple layers of improvements, and I will definitely go into them in details. But just as a refresher, we are like when we are building with the widgets in Flutter, it's almost always like we're freely modifying values as much as we want, and it's exactly the same situation with opacity and other values. But with blur, when you are applying a blur, so let's compare it with another effect, for example. So if we're comparing it with a grayscale effect, it's taken an image, it looks at the current pixel, and then it multiplies it with another value that will make that pixel look grayish. So it is one operation. For each pixel, we have one operation. So we call it constant time because we're talking in terms of the function in the pixel level. So it is constant time. But for a blur effect, it needs to go through the neighboring pixels. So if you increase the sigma, let's say if the sigma is 1, you probably need to go 2 pixels to the left, 2 pixels to the right, like 2 pixels in each way. Like you will go from let's say if it is 5 by 5, it's like 25 operations just to read and get the value of each neighboring pixel, and then you're going to multiply them and add them all together and divide them by the size of the kernel, and then you're going to get the final value. So that's what they mean here. It is just computationally, algorithmically speaking, much more complicated. But I think it is the only, I don't think there are so many other exceptions. I will show other exceptions like this one, but in Flutter, almost because we get used to it, we have this freedom that whatever we edit is going to be the same. It doesn't matter what the value is. But blur is one of those really rare cases where it actually matters. And if 100 looks good for the sigma, 100 looks good, and 60 looks good. If you put 60, you're gonna gain a lot more in terms of performance. So I think the takeaway as a user, the takeaway as a Flutter developer is that if you can achieve the desired effect with a smaller number, do it. So don't try by increasing the number, try by decreasing the number to get a better performance.
Yeah, absolutely. Even opacity is expensive, and we were just describing it as constant time, but that's because it unlocks this whole extra pass at the compositing layer where you now do have to consider the pixels below it, whereas before they just got clipped out and completely deleted. So, opacity not necessarily super cheap either. That's
Yeah,
also not specific to Flutter. Every rendering
I
toolkit in the
mean,
universe has to do a
yeah.
lot of work when you add opacity.
Yeah, I mean, opacity, clipping, all of these, they create new layers, at least in Flutter. And the cost, the initial cost of creating the layer is what is common between all of them. The only differentiation with the blur is that is not like opacity is expensive by its nature because it requires creating a new layer because it needs to know what's behind it, not like the other filters. And anything else that require having a new extra layer in Flutter will have the same initial cost. The only difference is that the blur is the more you increase it, the more it's actually going to be. Someone asked if it is exponentially. I mean, it is n squared, the algorithm in general. If you want to implement this, if you want to implement the algorithm correctly, it's going to be n squared. So I think we can reduce that. Flutter reduces that by a huge amount, just like the most modern UI frameworks.
Yeah. Okay, so you've got a lot of other values here to play with, besides
Yeah.
just blur. Are there any that you want to walk through?
Oh yeah. Clearly, we were talking about the tile mode, which is what happened at the edge here. So clamp is the one where, as you can see, it's like clipping it, and there is nothing happening there. Repeat. So is like, as you can see here, it changes what happens at the edge. So from when I go from clamp to repeated, it changes that. So that also is the cause of flickering when you use the blur effect and when you're scrolling, because you're at the edge and you don't know what values do you get them from. So when you say repeated, you take a copy of this image and you put it at the top. So this image, you put it at the top and you get the value from. So here, if you are at this edge, repeated is going to take a copy of this image, put it at the top, and then now we have more extra leg room to play with. Mirror is going to take the picture and flip it. So you can see the difference between repeated
Yeah,
and
yeah.
mirror easily. Decal is the most interesting one because it's the only one that gives us smooth edges. So all of the others are clipped. This one gives us smooth edges. But I think enough about blur because it's the only one that everyone knows about. The other image filters, there are other image filters. So for example, I probably need to go reference this Flutter image filter is when we go to the documentation, image filter, the main one we use is image filter.blur. But we also have to remember that image filter is class, and then there is also another implementation of it. So if you use a backdrop filter, you can use more than just an image filter. You can even use a color filter, which is a whole other set of features. So for example, what you can do with a color matrix filter, you can obviously, let's take it back to the normal view. You can grayscale an image, which here shows the values that we are going to apply. This editor is just to help you visualize that. So grayscale the image is a constant time operation, so it's very fast compared to the blur. Sepia effect, like a vintage looking image, and vertical colors. I think this one is using the hue color. I don't know what's the name of it. Is like there is the color of all RGB values, and then the invert color is the color on the opposite side of the circle that describes the image. But all of these are just pre-made selections of the most popular like color filters. Some of them are used in UI development. Some of them are definitely not used for UI development.
Like this one.
Yeah, this one is nice for the image itself, and they actually I think this is like they put the light inside of them, so when they turn the light on, it looks like this, right?
Yeah. This is reminding me of like the movie Predator or something, like its view of the world. But yeah, so on the left there, we're looking at a panel that kind of reminds me of any photo editing software, right?
Yeah, I
And
mean,
which
we
is,
are
of
not
course,
limited to blur
doing
only,
the
right?
same things.
Yeah. I mean, with the color matrix, we have literally access to the pixel, and then we can define what to do with that pixel. Like we can multiply it, we can desaturate it or saturate it. Like we can do whatever we want on the pixel level in terms of the color, but we cannot we can only change the pixel by being there. So that's the only limitation for a color matrix. It does not extend beyond the current pixel, and it only changes the color of that current pixel. There is another one, which is a matrix, which is also part of the image filters. We can use it to actually do the effects that we use in a transform widgets. For example, scaling back, rotation again, skewing on all of those effects. But I mean, this is possible, but the reason I mention it is possible here in terms of the image filter is because we can later figure out that we can compose multiple image filters. So we don't need to use like a transform widget and an image filter widget in order to create such a thing, because we can compose all of these effects. The other two are like, I mean, not very new, but just not very common. So one of them is called erode, for erosion. So this one, I will think that using a picture without with transparency will describe it better. So as you can see here, I'm increasing the X and somehow the shapes are getting smaller. So it is somehow not minifying them, but it's looking at the edges of each color, of each pixel, and then looking at the colors of the neighboring pixels the same way as a blur does. So this is actually one of the other cases where if you increase the radius, it's actually gonna be take more it's not gonna be faster. It's like it's gonna be slower. The more the greater the X or the Y, the more performance is gonna take a hint on. But yeah, so this is what erosion does, and dilation does literally the opposite of that. So it expands it. So, and I'm gonna take these examples that may look like you will not be able to use them at all, and see how we can use them in real life. The final one is color blending. Like color blending is a whole different set of functions that you can use for basic image filtering, but this playground here is just a way of us for simply understanding like what a simple color blender algorithm does. For example, here we are blending the image in the background with let's say the color red. So when we are saying the blend mode is SRC, we can see that we are just showing the color and nothing else. If it is the destination, the ST, we are showing this color. So if we put them together, SRC in, nothing happening. That's why we have another image. So that's why it happens in the transparent image. So SRC in, so it's filling the image, but only in the transparent part. So I think all of these are just like the basics. I wanted to show all the building blocks. So all of this is building blocks that are really not used unless you need them, but all of these are possible filters that you can use out of the box with Flutter. I mean, unless there are any questions so far, I think we can go ahead and see what we can do with these basic filters without doing anything extra.
Yeah. I do have another interesting question. Well, I don't know. The person in the chat had a thing, and I'm going to expand on it ever so slightly. So they're asking, is this made with Flutter? And we can see the debug in the, exactly. So this is made in Flutter, but also is the source code of this playground public?
Whatever you're seeing is all public. It's all ready for you to use. Whatever I'm using, you're going to be able to use. Just make sure you're on master, because I'm using a feature that was released 2 days ago. Yeah, it's a cool one. It deserves me breaking the notion of using Flutter stable, but it's worth it.
Yeah, I mean, I haven't been on Flutter stable in years. I'm only on master. Yeah. So okay, wow, that's amazing. We don't have to go into what this feature was that came out 2 days ago that you're using, but that's incredible that it landed just in time for this. Is the source code for this on that same repository, or is it somewhere else?
Yeah. So here, for example, here I'm looking at the basic image filters, right? So if I go back to the code, to take a look at the code, I have sections 1, 2, 3, 4, 5. So this is the first section. If I go to the basics, I have the blur one. The basic filters is obviously just an overview of it. But for each of these filters, for example, the dilation and the erosion, for example, this is the code for them and how they are being updated. If we take a look at it very quickly, I think it's really interesting, because all I'm doing in all of these filters is obviously all of these files are just for different controls. But one thing that is common between all of them is that I'm returning just one. Whenever the filter changes, it's going to get back to me with an image filter. That image filter can be a color filter or an image filter.
Okay. And can you explain, and maybe we can defer this for when we write one at the end, but like the implications of what you just said?
Yeah. So here, for example, here it's just the way I organized this playground. You can see, for example, here I'm just having a section, or like a function that returns to me this exact part, which is the parameters. So here everything is shared, but then when it comes to adjust the parameters, you can see parameters are different for each of these filters.
Right.
So for example, let's say I go to color blending. There is a file for color blending, and that file has only access to the color blending
Parameters.
methods, right? But what I need from it is just a final image filter object. So here is just creating an image filter and updating it based on. So here, for example, we're using an image filter called color filter.mod, and this is an image filter because it's a color filter again. So we don't need to use extra widgets to use, like, there is a widget called color filter that is only used for color filters, but we can use it straight away using the a normal backdrop filter, because when we get access to backdrop filter, we can do a lot of amazing stuff compared to just a normal widget.
Gotcha. Okay, cool. All right. So we've looked at, is it time to write, to play with some of this code more, or do you have other things to
one more
show?
thing, I guess, is let me see. So we saw the basics, right? Like, it's what everyone already uses every day, but is what we can do with them when we combine them. So for example, this one here, I would call it like, we do not have access to a lens like blur. Like, obviously when we say blur, we just being so generous, because there are like 20-30 types of blurs, and each of them produces a different result. The one we use in Flutter is called Gaussian blur. It's just the natural one. But
most common.
there is another one that if you ask any photographer about it, they will be like, what is a blur? They will be like, okay, a blur is when you take a picture in Tokyo and the neon lights behind, they start to circle out, or like they have a very specific idea of what a blur is. That there is it's called bokeh and lens blur, but it's just not like a normal blur. So the way we could do something similar to it, but not very clearly, is if we take one of those morphograph, I forgot what is it called, the thing that does dilation and erosion. So if we increase it, you will see, like, because it increases the shapes, it goes into the how the shape is made, and it sometimes just expand on the shape itself, and then we apply a blur on top of it. We're going to end up with like something that looks like a lens blur, but obviously it's not exactly the same, but it's just a lookalike, because we used a feature in all image filters that I find really interesting. If I take a look at the code for this one, lens like blur, we'll see how this is being used. So here you can use compose. So compose is another constructor for image filters where you have an inner and outer filter. So the inner is the one that will be applied first, and then the outer is the one that will be applied on top of it. And that obviously makes a lot of difference. In another example, the other example is saturated blur. So there is actually a couple of issues in the Flutter framework already, but luckily, I don't know how I'm getting lucky with this, but most of this stuff that I'm already about to show right now is already in PR, and people are making it, so I don't even get a second to complain. But here is the thing. In iOS, when you blur something, it usually they add saturation to it, especially based on we're on a dark theme or a light theme. So it's not like just blur the big background and add a layer to it. They actually increase the saturation, which is the lighting uh, of those pixels in a way that looks good. So for example, here, if we're looking at the blur at the top, so I'm increasing the blur of the app bar at the top so that the content behind it is blurred. But in so many cases, the content is not readable. And for accessibility, one trick to increase the access to the readability of something is to do the contrast. So how do we increase the contrast? Well, they have came up with two presets, one for the light theme. If you are in a light theme, you can increase it. And as you can see, obviously it depends on the application, but you can reuse this code for anything else. So if you're in a light theme or in a dark theme, it just try to adjust to that. These light and dark theme are based on the Cupertino design guidelines. So I took them away from there. It's not like just random light and dark presets. But yeah, in the end, they are just there to increase they are called saturated, but they are there just to increase the contrast, and it will be easily more readable.
And the goal here you're talking is to read the text above or the text below?
The text above is always the thing important. Like the one behind is just to get
Oh, so
rid of
that we
it.
don't. Right. Okay. So can you go back and show where color list view was less built? Oh, sorry, in the UI, where it was less readable, and then like what you were changing to make it more readable?
Well, sure. Let's for example remove here.
Right.
Let me see. This playground has a lot. So use color filter.
Yeah, the contrast isn't super high here. Colorful list view. So those are the words we're trying to read, and
Yeah, I
it's
think
occasionally legible, but not always.
Yeah, obviously we want to do it without increasing the blur sigma a lot, right? So we know by now that increasing the blur sigma is like, if you want to avoid it, just avoid it. But I don't think this example is pretty describable of the text that we want to do. It just describes the preset and how they will look like. But I mean, can we see the difference? Can we see the difference easily here on the stream, like between the dark preset and the light preset? Unless it's...
Well, I think basically, I'm not sure if this is what you're going for, but when you increase the sigma, then to my eye, the background just becomes more nothing. So the text above it is easier to read. And I'm
yeah,
not
I mean,
sure if that's the effect you were talking about.
Sure. I mean, for whenever we increase the sigma, it's obviously going to makes it into the nothingness, right? So I think the light and dark presets are more into like how does it blend really well with the content itself. But I mean, in the motivation for it, it was more about contrast. I don't think this example serves as a best example for showing the contrast problem and the readability problem. But the way I see it right now is that is a showcase of how you can use color filter with a blur. But I don't think this is actually a pretty good example describing the contrast issue. It's just what people were complaining, the reason that they needed this mainly.
Yeah. Yeah. Okay. By
So,
the way, folks in the chat there, I've got a couple really great questions from you all starred. So as we keep going through here and your questions aren't being surfaced immediately, know that they're not being ignored.
okay, I just wanted to show the code for this one because it's like using well, it's a lot of if else's here, but is one is a color filter and the other is a blur filter, and we're applying which one first based on on whatever the playground is deciding for us here. I think a saturated lens blur. Shader mask is obviously this is how you can combine color blending techniques with just normally any I mean color blending in the way that we can decide what to appear, like is it the source or the destination, and the other filters are like blur here. So in this way, using shader mask, we are able to create a progressive blur based on the gradient stop. So it's like here coming from the bottom, it's a bit more progressive, but here it combines multiple things. So it combines shader mask, obviously, because it takes a gradient, and then color blending, because we are deciding, for example, here, if I take this one, it's just showing I think the source or the destination. I'm already falling behind on this one, but that is what color blending enables us to do. But the other part is obviously just uh, the gradient
Doing it
slope
for
in order
right,
to
right, right.
control the progressiveness there. The final one is just motion blur, is just a cool demo, but it does not require a lot of um, um, a lot of
Oh, that's kind of cool.
yeah, it's cool because it uses only the normal blur we know. So we don't have motion blur in Flutter, like we don't have a blur called motion blur. But because we have access to the signal on the x-axis and the y-axis, we can emulate, just like we did with the lens blur, we can emulate what motion blur looks like. So we only blur on one way, which is we blur on the y-axis. So here you can probably see the difference. If I do it on a very fast, very long list, you can tell which one is looking smoother. I don't know. Hopefully the frames are not dropping, but I hope you can see it.
Yeah, on the live stream, subtle things like that can be hard to fully follow. I'm
Oh,
sure
really?
in person
Well,
on the
glad we
thing,
have the
it
code
looks
for it.
here.
They can try it for themselves, but you can
Yeah,
tell it's a pretty big difference between the two. And it works just because we are able to blur on one axis. That's the main thing. But we combined multiple effects in order to get really cool. We use the building blocks in order to create some really interesting effects in the end, just using
yeah.
building blocks in Flutter.
So speaking, you said you were able to combine. Sorry, I just hit my microphone. That might have been loud for everyone. You mentioned that you were able to combine multiple effects, and that I think is a perfect time to bring up one question from the chat. Ivan asks, is there a way to combine an arbitrary number of filters and not just two?
Yes, you can, because Compose takes a filter, and it takes an inner and outer filter. And the inner filter is obviously the first one that gets applied. So if you want the inner filter to compose again, so you will see it's like compose, and then the inner filter, you give it another image filter compose, where you compose
Hmm.
others, and then you give it another image filter compose to compose others. So it's like using compose is obviously just gives you access to two, but you can think of it as just like a tree, and this is the top of the
I was
tree.
gonna.
You're like compose, 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 but I don't think you want to do a number of filters. You want to stick with a really small.
Yeah, stick to the rivers and the lakes you're used to. No, I was you used the word tree as well, but I was pretty amused thinking about how this is, yet another tree in Flutter. We've always
Oh,
had the big tree everyone knows about. There's the layer tree, there's other trees,
oh yeah,
and now
we have.
there's the semantics tree, and now there's also the image filter tree as introduced by
Yeah.
this episode.
Oh yeah. I guess Flutter is just trees but reverted. Like the trees
Yeah, I
should
know.
start from the bottom, but our trees are always from the top.
Yeah, right. True. Yeah. So it. Oh, does that mean we're in like the upside down from
Stranger Things.
Stranger Things? Yeah, it's also
Yes, we are.
Halloween, so we might. Are we in the upside down? Is this the bad place?
Yeah, I guess it is. We're just not having the powers to see everything.
Yeah. Right. Right. Uh, cool. Okay. All right. So, what's next here?
Well, what's next is that we have seen the basics, we composed some, so maybe you take us to a spin and compose some effects. So I saw a really, when I was looking at the documentation from Apple, I saw, like, obviously they have documentation about their image filters and everything that they can do. We can do is just for example, it's like they have the whole page of what are the supported image filters by default. It's just they have constructors for them. But for example, blur filters, we have seen a couple of them. We have seen color adjustment ones for increasing the hue and the saturation. We have seen the composite operations, which are the blending one, and we have seen the general color effects one, like sepia effects and grayscale, and they have other effects obviously, but all of them are just literally like shaders in the end. They just have constructors for them. But when I was looking at their documentation, they have a couple of recipes for some really interesting ways you can combine these effects. One of them was selectively focusing on an image. So I wanted to replicate that in Flutter based on this recipe and see how can we make it in Flutter, and also how can we take it even further. So I think we'll just start with a new project. Maybe we'll take it from my side to your side, and then I'll try to describe the best way of what we are doing, or how we can do it. But mainly what we have is that we will have an image, we will have a Flutter app that will have an image, and on that image we would like to click on some portions of the image, and the portion that we click on is going to be somehow highlighted in a way that it is smoothly integrated with the background, and only the part that we are highlighting is the part that is fully visible, as you can see here, just this way. But we want to do it in our different way, not following exactly what they have. So shall we do that?
Yeah, absolutely. And I don't know, you just stuck the landing on this, because folks were asking in chat earlier about like a depth of field filter. And I think this is going to constitute a kind of naive one, right?
I mean, we are emulating since the beginning of the day. Obviously, you can create like a pretty close one using just shaders, but here we're gonna try to do something without using shaders, like just using the basic building blocks of Flutter, no external packages or nothing. But as you said it, this is pretty close to it. Like obviously we cannot define exactly depth of field in to be one effect for all of them, but I think in our context we can call it depth of field because we are trying to bring the attention of the user into a specific place in the UI. Is not like it has multiple layers where you're like focusing on this one or that one, because we wouldn't be able to tell the shape of the thing, but we can do it at least at the shape of the gradient, whatever the gradient gives us.
Right. Yeah, I think anyone who's taken pictures with cameras knows, but a depth of field is like the light passes through the lens and is physically blurry based on the aperture and everything, and so it hits the sensor with varying amounts of accuracy or various amounts of blur based on how far away it was. But then once it does that, it doesn't, like, you just have a color value. It doesn't capture with it like how far it traveled away. And so you probably have to do some kind of AI stuff to understand what was the structure of this image and how far away different things were. And I don't know, maybe Android has this. iOS does have a way where you can kind of in post add like you can apply portrait mode to any picture, and it's got to do something like this, or like what I was just describing. But yeah, in terms of what we're about to see here, it's a just really, really naive. We're going to pretend this spot was what's in focus and everything else is blurry, and hopefully that's what we want. But I think it's
Yeah.
super, super cool. So yeah, keep going.
Yeah, well, I always try to explain that depth of field by doing this trick that we used to do when we were young, which is like you hide one eye and then you have one finger, and then you look at the finger that is close to your eye, and how you change the focus from the background to seeing what's in front of you, which is your finger or anything in front, is like very smooth operation. So I mean, I think you have already the starting code for this project, because we don't want to be doing almost all boring parts, which is taking an image and turning it into a raster image. Are you sharing your screen or is it mine? So
Your screen, yeah.
I think we'll do in your screen if you start a new project. Is that?
Oh, you're looking for me to do some coding?
Yeah. I guess
Oh.
you're better at coding live. You're so much used to it.
All right, I'm not set up for it, so allow me just a second here.
All right. Yeah, I mean, meanwhile, I'm just gonna try to explain how are we gonna use this in our context. Like, we will have an image, and then we will use the like user cursor if we are on a Mac or on a desktop device. But if we are in our let's say a phone is just wherever you have the finger, and we want to highlight that specific spot. So, and then the best bit, which is how we gonna use it to create real life, not just focusing, but real life use case out of that. I guess the documentation here is describing how it works, but in our case, we're gonna use a radial gradient because that's how focus works. It's radial.
All right. I think I'm almost ready. I recently got an ultra wide, so I remembered that I have to put it in a picture-in-picture situation to get the right aspect ratio, but I think I have that now. And let me share my screen here. Present. Share screen. Yeah, this is the one that we want. You are the one I want. Ooh, ooh, ooh. Wait, why is this covering everything? That's not what. Why is that happening? Oh, because it got confused. We want this mode. There we go. That's correct.
Okay, nice.
Lots of practice. Still no good at it. Oh, real quick. Sai, you had a good question. Can we get an episode with just the mathematics involved? I'm not necessarily 100% opposed to that, but we would cover so little in a given episode. So I would direct you to shadertoy.com, I believe is the domain, but definitely the book is called Shader Toy. No, not Shader, Book of Shaders.
Book of
Shader Toy is the
shaders.
website. Book of Shaders is, so not shadertoy.com. That is also cool, but it's not going to teach you anything. Book of Shaders is a walkthrough of the math, and it takes so much longer than a stream to get through. But until you really sit slowly and internalize it and absorb the trig and get what's going on, which is a slow process for each individual brain, when you look at least for me, when I look at shader code and I see the math and it's like cosine this, square inverse tangent that, and it's just like it all looks like completely random gibberish, uh, so it's a very slow process of basically stepping through and doing all the things of bookofshaders.com. Anyway, all right, so here I am, and
I guess we all want an episode with Jonas, who's gonna actually explain the math behind some of this stuff much more reliably.
You wouldn't believe how often I talk to the folks on the engine team who, are just unbelievable graphical wizards, and I say, so who's the person who knows the math and like writes the individual shaders, and they're all like, yeah, it isn't me, it's somebody. And I mean,
Actually,
this stuff is hard.
that's the one. I always go to Discord every single day to look at the Impeller channel. Oh man, it there is a lot of great work being done there, but I think there are very few people in the world who can actually do that.
Yes, yeah, that is true. A limitation of our meat computers we run in our heads.
Yeah.
All right. So I'm on a fresh Flutter create dash
Right.
empty, of course. So what do I need to do? I presume I need
Well,
to add
I
a
have
message.
the starter code for you here.
Oh.
I'm pretty sure it's gonna be a little bit
All right. So where do I
very
need to get that
basic,
from? Sorry.
and hopefully no external APIs are used. Yeah, no APIs were used here. So
Oh, you
let's
sent
do this.
me you sent me a gist. I see. Oh, you
Oh
sent
yeah,
it twice. I've just been really dense. Okay, so I'm gonna copy all of this code.
it's
Wait,
just
no.
one file, so it's great.
Yeah, you're a real hero for that. Okay, so I'm pasting in the. What are you doing? Pasting in the code. There we go. All right, closing the gist. And should I run it immediately, or do we want to walk through it?
Yeah, we can run it to see what are we doing first, because we are doing one thing a little bit differently, which is instead of just drawing the image using the image widget, we are drawing it using a custom painter. But that is mainly because we want to do canvas operation on our image. But while
Sorry, I accidentally ran a Flutter update by clicking the wrong button in VS Code.
yeah, well, it gives us the time. Hopefully, your connection is not that fast before I finish the explanation. But it's we're calling it selective focus, and we would like to draw the image first, but because we want to apply some operations on it, the image needs to be a raster image. So not an image in the way we think of it as an image widget. It needs to be a raster image. A raster image is basically when the image has been decoded by the decoder and has been transformed into something that Flutter can render synchronously. So when we say raster image, it means UI dot image, the image that is in the UI or in the engine side. And obviously that object, which is called image, does not hold the entire data for the image because that will be huge, but we already know about it. It's somewhere in the memory. So an image object is just a reference to all the decoded data of that single image in the memory. And that data is stored in RGB. So for each pixel, what are the RGB's colors that represent that color? So here, load image is just taking the image from the internet, resolving it into an object that is called UI image. And then we will have the object that we can use to play with in the canvas, because canvas API require a UI image to play with.
So this, right, so we're setting the underscore image property, which we can see here was the UI image, just as you said.
Yeah.
And then load image is called in init state, so that makes sense. And this is nullable, so we're going to see a null check in the build method somewhere, right? If image is not null, we're loading. Otherwise, we can start to do some fun stuff. All right, this is good starter code. And then we've got a custom painter, so this is where we're gonna. I didn't click the right thing to share, unfortunately. I don't think, because nothing is showing over top of my window. Like right now, the app is running, but it's not showing. So let me reshare my screen. I thought I clicked the right stuff, but apparently didn't. I'm going to now stop sharing my screen and try again. Share screen. Oh, I clicked window and not entire screen. Well, here's your problem. All right, I thought it was going to be done spinning by now.
Well, it's a macOS app, so I thought we're going to use an iOS app. But yes, that is what happens in a live stream. We need permission to load the image, because on macOS it's not enabled by default. Let me find where that is.
Yeah, actually. No, I can do that. I'm surprised we didn't get an error in the console for that.
Well, this is about image filters, not about error handling. I don't think I wrote the right code to get that stuff out.
No, not you. I'm surprised Xcode didn't bark at us in a way that we could. Yeah, definitely not. No finger pointing on you. Oh wait, am I opening the right one? I'm supposed to open the blue one, right? Or do I open the white one? I always forget. I hate that there's two. My brain is really bad when it's like there's A and B, and the one has a certain thing and the other has a different thing. My brain is just like, I don't want to remember which one's which.
Oh yeah, it's especially Xcode workspace and project, right? Like for me, it's like whatever Flutter suggests. But I think we can add it just from VS Code. I think you just go to the Mac
but
OS.
This is it, right? I just need an outgoing connection, and then I'm okay.
I wouldn't really know if that changes, but let's see.
I think
I usually just add it to the debug profile entitlements, if that does it. It's like,
I don't have any idea how to do what you just described.
Oh, well, it does. It does. I guess graphical user interfaces are much more making more sense. But yeah, we just draw the image instead of using image filter. We just draw it. Instead of using image widget, we just draw it using a custom painter. So now what do we want to apply is obviously we want to blur the entire thing, the entire image. And then there is one single spot that we will not be blurring, but it will be gradually like clear, but the rest is blurred, right? So I think we should first try to blur the thing. So like try to draw the image blurred. So if we go to the canvas paint method, we can just say canvas draw. We can just say canvas draw again, like the
before or after the probably before.
Yeah, after. Yeah. So we'll draw the image again,
Okay.
draw the image again, pass the image, and then at the offset 0. This time, the only difference is that the paint object is going to have blur to it. So paint, and then we can do it inline dot, 2 dots, I guess. Yeah, 2 dots.
Yep.
Image filter
Image
is
filter. Okay.
going to be image filter blur.
Okay. I didn't guess the correct code.
Well, no, we need to import the UI, I guess, unless it's imported, but with UI. I think it's aliased as UI. Yeah, he did.
I see. Aha.
That's why I shouldn't give a starting code from there, but we can increase the blur and see how that looks like.
All right. So we just have Sigma X, Sigma Y, and tile mode. Great. It's almost like the demo you built mapped to the parameters of the functions. Huh.
Yeah.
Weird. So if it was 0 to start, so this will do nothing.
Right? Yeah. Well, actually, thank you for bringing that up. It does not do nothing. It's actually in the documentation. It is written in bold, not in bold, but it is very clear. Like they put a section on top of it. Image filters, because they do not know what makes a difference and what does not, they are like enabled. Like even if you don't do nothing, for example, image blur, and you have nothing done, it's actually enabled. It's actually expensive. It's actually doing something behind
even though nothing happens. Yeah.
And if you want to disable it,
but you get the same result, right?
Oh yeah, you get the same result. So they wouldn't be able to optimize for that. But they have a filter called enabled. So enabled is how you actually disable this if you wanted to start disabled point.
There we go. Look at that. It's pretty blurry now.
Well, we want to blur the X and the Y. And
oh, Billy, that's a blurry picture.
Yeah, that is blurry right now. I think the next thing we need to know is about custom painter, because we want to draw also the main image, which is the non-blurred one. So that's why we kept the original one. If we keep the original one, but then which one to draw first is obviously going to be the blurred one on top of it. So what we would like to do is you call this method, which is save layer, which we shouldn't be doing a lot because it's an expensive operation. We call it save layer, and it will take a rect that will be like taking the entire size of the image, so that when we apply the operation and then we come back, we have something to come back to. So we are just taking a screenshot of what we already have, which is the current image, and then we apply the blurring and the gradient. I think we can create a rect first. Save layer requires a rect first. So a rect, and then we'll create that rectangle.
So do we need to do like from size or something?
From top left, right, I think top left, right, LT, width height, rect like from top left. Yes.
Oh, I see.
Width height, yes, that one. So it starts at 0, 0, and then size width and size height. So we are taking a screenshot of whatever we already have painted. So the entire thing.
Makes sense.
And then when we call save layer, we just give it an empty paint. It doesn't do anything. After that, we're gonna draw our object that will draw the gradient. So that will be after the draw image. So after the second draw image, we will call
okay. All right. Sorry, I was looking at the return type.
Yeah, they are just non-return types. It's just one operation after the other. So we'll call canvas draw circle. So I mean, we can use also a simple rectangle, but a circle is easier to create here. Like we can create a circle from an offset, and that offset,
just like center it,
like offset. I think we can just call it offsets the name of the class.
I see.
Yeah. So offset, let's put it at 0.5, 0.5 for easier understanding of the coordinates.
Okay, so we're centering it.
Yeah.
Are we centering it? Is this like relative, or am I giving it
Oh, yeah,
half
it
of a
is
pixel?
relative to the image. So 0.5,
So we need to do
0.5.
size. Oh, okay. Okay.
Well, we will have to multiply it with the size for sure. Yeah, sorry, you're
Oh,
right.
okay. That's
We'll
what I
have
was
to-
wondering. Yeah.
Yes, right. Size width and size height.
All right. So the next thing was the radius, and we just give it
Yeah,
some
a
amount of
random
pixels or
one.
something.
Let's start with one, yeah. And then for the paint, we're going to create a paint object that will have a shader. Obviously, we'll use one of the Flutter shaders. We're not going to create a new one. So how
Okay.
we create one is using gradients like ui.gradient.radial. And let's try to fulfill the requirements by creating a basic one. I think, well, the center point is this time is also going to be the center point. So size 0.5 multiplied by the
off.
width, 0.5 multiplied by the height
Okay.
for the offset. Yeah.
Yeah. So captured that, and now we need a radius. So should this be the same value we had here?
Yeah. Same value.
Okay.
I think we're going to extract them at some point. And
Colors.
then it takes a list of
List
colors,
of colors. Okay.
of the gradient. I mean, we can start with a transparent one and then go to the black one because the color doesn't matter here. We just want to blend them in.
Stops. Do we care about defining the stops?
No, the default one is going to be from 0 to 1, so I think that should be fine. And
Okay.
I hope this will render something. Well, I think we need to call restore because we will apply this on top. So the final thing is canvas.restore so that we go back to the original one. And
All right.
is it rendering anything?
We're about to find out.
Oh,
I clicked the button.
I thought it's so old, and I was like, why is it not rendering anything?
Actually, I seem to have like screwed up my terminal. Did I make a second terminal? Is that what happened? Come back.
Yeah, I don't know what that terminal is. It's definitely.
Here we go.
Oh, well, we have the
Oh,
circle. So now what do we want
yeah.
to do?
And you can kind of see the flowers in the middle of the circle.
Yeah, so we want to get rid of that black, right? So that black is not something that we want. We want it to blend in with the blur, right? And if you remember, we saw the color blend in once is when you have a transparent and non-transparent part. So if we want to cover only the non-transparent part, which is the dark bit here, we will use a specific color blend-in for that. So that's why we took a look at the color blend-in once. So color blends is actually a feature not in the gradient, but in the paint, I think, paint mode. So in the paint object, we will say dot, after that, dot, and blend mode. And let's try the basic ones. Blend mode, DST, out, source, out. So we see DST first, so we can see what's DST here. In this case, DST, what does that do? Does do nothing.
Basically,
so
no effect. Yeah.
Yeah. So
this is destination.
Sorry.
DST stands for destination.
Oh, destination, yeah. And SRC is for source. So I just wanted to make sure we know what this color blending are doing. So yeah, so one is showing the entire thing and the other is just showing a portion of it. So I mean, without too much in detail, is like DST in is how we are gonna like fill in only the color bit. So DST in, we're gonna just show the part where we have a color. Yay! We have used multiple effects to create this. Now, obviously, we know the rest. Like we can do the rest as we want. Like we can go beyond and just have like a gesture detector and control where that focus is and how big it is, and we can also control the blur. But one more thing I wanted to do is, because we are combining multiple effects, if you go back to the paint object where we did the blur, we can also do color filter. Okay, let's see this one actually first. How big is it when it goes big? Yeah.
This one seems too big. We'll go in the
150.
middle. All right. So what were you Yeah.
Yeah.
What I want to do at the end before we're done here is add a click handler so we can click and drag around and move the center of the
All right.
circle. I think that'll be
I,
fun.
I wanted to do that. I'm just making sure we're not gonna go beyond time because you told me we don't have enough time, and I have
Yeah,
one
but
or two
that'll be
more things
fun.
to
So we're
share.
gonna do that. Okay. So what's the next? You were
The
about to
next
propose the next thing. Yeah.
Yeah, is because we are talking about focusing. Why? I mean, we are focusing by using the blur effect here, but I mean, we want to focus on that specific part, so we can take some of it already by graying out the part that is not visible. So we can gray out only the part that's not visible, and that will be like a good like extreme combination of color blending, like
Yeah.
gradients and color filters. So if we go to the Flutter documentation for color filters, they actually have it's in the color filters class. They have a one color filter that is only just for the graying out. I think if we go to the color filter grayscale. So if we take that away, we just copy that one because it's just values that they have
Oh, we
measured that
literally
these
am
these
gonna
are
like
the RGB
literally do
values
this.
for gray.
Okay, that's funny.
So let's create an object with that grayscale. And
Goodness gracious.
yeah, if you have formatting enabled, it's just gonna take it. It's gonna make it weird, but it doesn't look like
Yeah.
it did. There's
No, I had
oh yeah,
invalid. No, it did. Yeah. Oh, so
yeah,
we can do this.
yes,
I think that'll
that
that'd be
is
a problem. Yeah,
that
cool.
is a great Dart format trick to
I
keep this
know.
matrix looking like a matrix.
Yep. Okay, so where do we use this grayscale object?
Yeah, we use it. Obviously, now we have multiple ways we can use image filter compose, or in the
Mm.
another filter called color filter. So it will combine them by default. So if we do dot
And we're
dot again next to the paint object after the image filter,
okay. This one. I was wondering which one.
dot dot color filter.
Equals grayscale.
Yes, let's see.
Oh, you have to type it the same way.
Ta-da.
That's pretty cool. Okay, so let's talk about how why is this working? Because save layer is where the magic is happening here. So we're drawing the image, and then save layer is I'm going to be really, really, really hand wavy here, but like save layer is basically saying set aside everything that this stuff so far is going to render over there and then begin a new universe on top of it. And so that's why everything that happens between the save layer and the restore layer only impacts itself and doesn't impact the stuff outside of the save layer. I gave a talk called the life cycle of a render object that goes into save layer and how it can kind of be like almost parentheses in math, where it can tell you like this number does multiply by all those things, or like it doesn't multiply by those things. Maybe it only multiplies by this one. And anyway, that's what save layer is doing, and it's why the grayscale and the blur and whatnot are not affecting the plain image that we drew up top. And Raouf, you were a very good citizen by saying that save layer is a method you do not want to call willy-nilly because it is expensive. Anytime you grow the size of the layer tree, you are definitely making that frame harder to render. So if you render it once and it just sits there, like that's fine. If it's part of an animation and it's moving and you're scrolling or something, then it could become complicated.
Yeah, I mean, it's literally taken a copy of what already exists in raw binary format. So it is kind of expensive computationally and memory wise as well. So better be careful with that. But once you can use it, you can achieve some great stuff with it. I
Some
think
cool
now
effects,
you
yeah.
wanted to do the gesture detector, right?
Yeah, let's do this. So I'm gonna pass in like the center point here.
Yeah.
So I guess we'll add two things here. This will be final int center x, I guess, or like we'll just call it x. Final int y. There's better parameter names we could have given this. Or why don't we just take an offset? That'll be easier.
Yeah, I would say that only need an offset. Obviously, the radius, we don't need to change it here. We can do it later.
Yep. So now the offset here. Oh, no, that's not what we want. The offset was not this one either. It was this one. So this would be our center, is what I believe we called it. And then this one would also be the center. All right, so now our interactive painter needs a center. So we will pass in that, and that's going to be the offset. And here we'll just store an X and a Y. And now here we can say int X equals, or final X equals something. Oh, it's not final, of course.
I think we'll store it as an offset. We can. I think so.
Like true.
An offset object.
And we'll figure out how to initialize it in a second. So this will now just become center again. What should our initial value for this be?
Oh, what it is now, 0.5, 0.5.
Oh, right, because we can do the multiplying in. Well, so I was going to do the final computation values here, but I guess we could use a layout builder to get the size up top, because later, like the thing is, we get a size value down here, but we need a similar value up top so that we can, I think, fully.
No. I think the values that we are storing over there are relative. So 0.5, 0.5 is the middle. Like the values that we are passing, like they are being multiplied inside the thing itself. So here, like in this at the stateful widget level, we are talking about values from 0 to 1, and that's it. Like it's relative, and we will convert it later on with the gesture detector.
All right, I think we're imagining different implementations, but let's. I think it'll be time to get into that. So I'm going to wrap the whole body in a gesture detector. And this will get a child, and then we'll add another closing paren here. And then we say what, on drag or on pan? What's the parameter that we want here?
I think on pan start and on pan end, and on pan update.
Yeah, on pan update is potentially enough, or on pan start to know where they clicked.
I remember doing a talk with all the parameters for gesture detector, and that thing can fill a whole page.
Yeah, absolutely. All right, so I'm going to add two different things here. This is going to be on pan. This will be void on pan start. That's going to take a offset pan start details probably. No, I don't know. So this takes a drag start details.
Oh, APIs.
And then we'll do the same thing for on pan update, which is probably going to take a drag update details. There we go. So now this is on pan start and on pan update. Cool. Now here we kind of, I think, need to basically just capture the like offs. Actually, what is let's go look at this class. So the local or the global position, either of those.
I think that's where they do the magic. I think because if we get the global, it will give us the relative one. I think at least that's what I had imagined in my head, because if we take the global, we can convert it into local, and it will give us something where we are like have access to the box size in the end. So we're gonna make it relative.
Interesting. Okay. So we can basically here just say pan start equals, and then I guess we could do an on pan end as well and just clear this out. We'll do that in a second. So pan start is going to be details dot global or local?
Global position. And
okay. I didn't know that this was relative. Interesting.
Then we will make it relative, but we'll have to do this kind of thing where we're like, we get the box of what is in the drag area. So it's like if we create a box object, like a box object that will give us the width and the height by default, like I think that's what you were referring to. Like you wanted to use a layout builder so that you can get
Yeah.
access to the size.
Yeah.
And the handy thing about the drag details is that they give us the render object of the entire thing that's inside, so we can use it to get the box sizes without having to use a layout builder. So I think the trick is to create like a box, and if we create a final object called box in there.
In start or in update?
I will share them, but yeah, in start, let's start with in start, final box.
Interesting. I don't know. Yeah. So what class are we using for this?
Context dot get global get like render object. So it will give us the render object there. Get render. Is it get? No.
Yeah. So the code that you're proposing here, I don't think I'm too familiar with. So
I think it's find render object. Yeah, sorry. Find
render object.
Yeah, find render object, and then
okay.
say as render box, just to cast it as the right object there, and the render box is the one that will give us access to the width and the height. So now box will have size. Box will have size, unless.
Got it. Okay. And so the trick here, because we're writing in the main widget that contains the scaffold, it's going to be the whole screen, is what you're saying.
Yes, I think that is the miscommunication where it was not really getting, like layout builder is going to give us precise. This one is because just we are in the situation where the widget is the whole thing.
Screen. So, yeah. Okay. All right. So that works. So now we have the box, so we can. I think I still probably want to. Well, I guess we can just save the size. Maybe. How about that?
I don't know what you need. I mean, we can save them for sure, but there is an API in the details object where we'll like be able to use. For example, see here, I'm looking just at my notes where it says box.global to local. So if after line 78 we call box, then global to local, so that it does the conversion of the coordinates, we will pass the global position, and the global position is.
So that is our pan start.
Yes, that is our pan start.
Something's not right. It takes an offset, which is what we had, I thought.
Maybe it's nullable. Maybe just because we make it nullable.
Oh, because okay, get out of here. I see. I saved this. So we actually just want to do this. This is what we want to do.
All right. Yeah. I think that definitely does it.
This is what we want.
Pan start. Yeah.
All right. Yeah. I've never. I know these are here. I've basically never really used these. So this is a different way, not the non-layout builder way, to grab these coordinates. Okay.
Oh yeah, I'm probably being. This is the only thing I have in mind because it's the only thing I have prepared. Probably there are so many other ways of doing it.
And so then we'll just end this and say pan start equals null again. So that's whatever. All right. So now we're in the on pan update where we're actually going to change the center value. That is what we need to do in on pan update. And then of course we have to call set state eventually.
Yeah.
So I want to first just print pan start and see that is working. So I'm going to refresh here. And our circle. So we can see, I think that is working nicely, but we never normalized center. I'm passing it in totally straight away. So that actually makes sense that it's putting the circle up here.
Where we can do the box, because now the box gives us the access to the size, so we can normalize it there. So
oh, true. So we could do the same thing of center. Now we'll get one bad frame here, but I'm not going to worry about it.
Yeah. So I think a box has a feature called size. Just size.
Oh,
Oh, okay, okay. I see. It's doing
well, that
this.
didn't work at all. So
Oh, that's just updating it, I guess. Size,
so yeah,
size,
but this is
size.
probably a size, not an offset. Size, are you saying, or
Yeah,
size?
size dot width, and so obviously size dot width. Okay, now we're gonna normalize it obviously by getting the pan start x and dividing there. So it's
So
like pan
this should
start.
work, right? Oh no, it didn't. Why is center not? Oh, we're not calling set state.
Well, we're not calling it, but I think what we will need
And
to
I'm
do
not
with
panning.
uh
I'm literally not panning.
yeah.
All right, so this is kind of why I was thinking we'd do the layout builder, but let's see if this even centers when we start panning. Oh, it doesn't. So what is center
Uh
being set to?
so can you try to like
Actually, listen to what you want me to type.
yeah, so on the offset one we'll just get
Hmm.
pan start and uh, pan start, yeah, in the at the line 80. If we
Okay.
call, yeah, and then like divide pan start has like a local position
Wait, where
dx.
did? Oh, details, right? Is what you're saying. So
Sorry, no, I mean like pan start dot pan
what is?
start.
Oh, I set that. That's literally my variable you're
Yeah, yeah,
talking
you
about here.
already said it. So
Okay.
pan start dot x dx
DX.
or x, yeah, and then
Uh-huh.
divide it by the width. That's how we get the normalized value for x, and then we'll do it for y.
Oh,
Uh,
so this would be box dot width.
box dot size dot width, yeah, size dot width, yeah.
Whew, making this look real hard here.
Sorry. Dot height.
Okay, so it doesn't like dx and dy.
I
Let's
don't
bring
know
it
why is that.
there
Okay,
unconditionally
maybe.
because pan start is.
All right, that fixes it.
Okay, so now again, this isn't going to do anything until we start dragging, but we do have. Oh, it still isn't centering it.
Think they're normalized now. Are we? So yeah, that's a good.
Yes. Oh no, center is printing. Look at it. It's printing like really, really, really small values. So our math
I
here
mean, those
isn't
are the
quite right.
normalized ones, so I think that's what we need. Oh, maybe because we are doing pan and is setting it now. It's not. Is pan
No.
and? Oh,
So
okay.
the issue here, I think now because I'm just using center and I'm not
Oh,
using, so this now needs to be center
yeah, exactly that
dot
one.
dx, and this needs to be center dot dy. That's the issue. So again, here I was imagining a super different implementation when I changed those lines. So that is our issue. All right, this should now work.
100%.
Right. So there we go. It centered it. We know how to type simple code. Look at us.
All right. Well, I guess as programmers, one is way better than two. Yeah,
We're
one is
certainly,
always better.
this has not been a great case study for pair programming. That's true.
Yes.
But we could get better. We could do it. All right. So
Um,
now we can finally begin to implement on pan update. And because
it's the
you've
same.
thought about the implementation before, I'm not going to just type random things.
Yeah,
What do I need to type?
it's the same. We're gonna
Same
just
stuff, right?
have the same implementation. Let's not be productive. Let's just have the same implementation. We can share the code later, but it's literally the same
Yep.
code, every single bit of it. So it's like the same
Okay, so
handler of
this
the
isn't
function.
pan start. This is like current.
I think
So
those can be local. We don't need to make it hard for us.
and so now we do that, and we can get rid of these prints, get rid of this. So now I'll grab this again. And this center now becomes like this. Is this right?
I hope so, because I'm also starting to not look right at the code. No, it's not
No?
details.
Well, let's make sure that this is firing. Details, and then we want like global position we were doing.
On pan update. Yeah.
All right, this is working and it's looking correct. So now I'm going to print center and get rid of this. Yeah, that is super working.
Okay.
Is there
I
like
think on pan
a
and is doing something. I just don't know what it is. Like, can you comment
so
on pan?
is it that should repaint is doing this?
Ah. I mean, let's call it true. Let's optimize it later.
Yeah. Hey, look at us.
Yes. All right,
Woo!
let's do the celebration one. What is it on Mac OS? Is it like this?
Oh, I have it turned off for me because
it's
I
not
know
even working for me.
you got it though. I put it in your background.
Okay. Yes, it's
Whoa!
working. Yes, finally.
All right, this is super cool. I love the like spy game kind of aspect here. Like I feel like I'm kind of looking through a what are these things called? Like a spyglass at maybe like a in the embassy's courtyard to watch different ambassadors discuss their nefarious plans.
Oh yeah.
Maybe I'm
I
over
mean,
reading into it.
that is a use case for it, but I have another one.
What's yours?
My use case, I can show it because it's if I can share my screen again, it will be real quick. And
Oh sure, yeah. Okay, I'll dip out and you can share your screen again.
all right, so onboarding with Blur. Oh, obviously, well, we implemented this, but let's see.
I can already tell
Go.
this picture looks familiar.
Yeah, it looks familiar. It does similar things. And
Randall, see ya. Thanks for tuning in.
thank you. And the use case that I had in mind, I just thought of this because I saw it before, and I think people couldn't, like we're saying, how that it is very hard to implement, was onboarding. So, like onboarding, when we focus on specific elements during onboarding, like say, go here, go there. In material, they say like they put like a circle around the object, something around the object to tell you like go here, go here. But what we can do, I did this, build this very simple, like it's literally using the same code there. It's just we are animating the positions. Like for example, here, you're like, we are highlighting the social feed, right? And then you click on it, and then it takes you to the objects, the other objects, which is like and the others. So you go here, it's really like nicely animated with a really nice curves. It takes you to the other button. So it's like you're really using selective focus to take focus of the user to where it should go. So you click here, and then it takes you here. And the final one that I almost got it to work is a robust one, which is like how you can take it to like go from this state to the other state. I don't want to do it in a way like, oh, just like that. I want to do it also progressively. So it's like it just takes it as much as possible and freshly or really nicely transitions into the other state. But yeah, like that is the use case that I found pretty reliable to do for such a filter.
Sweet. That's super cool. All right. Well, hey, that definitely brings us to time today. We completed the demo that we wanted to build. We got a super walkthrough of what's going on. Yeah, wrote a little code, saw a ton of demos, explored the various options available to us, reflected on how you basically rebuilt Photoshop in Flutter. So that's probably, I'd have to think real hard about all the other demos that have been built for Observable Flutter, but you're certainly on a real short list of most involved, coolest demos. Actually, Hanan with the game, the bouncing thing. I guess that wasn't built for. Yeah, he built that separately and then showed it off. So I don't know. Anyway, this is super cool. I really liked it. I appreciate all the effort that you put in after filing that issue to be like, hey, I can learn about image filters. This probably isn't, black magic, and just dove in, rolled up your sleeves, got familiar with it. And now, look, here we are 3 years later, a little bit
Yeah.
of and you're spreading that wisdom with everyone else. And I know you've been giving talks about image filters and shaders and whatnot for a while, so it didn't take you 3 years to learn what was going on. But man, really, really cool. So, Raouf, any final thoughts on your end before we sign off?
Not really, but I just built a package that does something related to this. So really quickly, the package is called Soft Edge Blur. The package is now very loved by the community. I did not expect to get all of that real quick, but seems like it's being used by a lot of people. But it uses the same concept. So whatever we have seen today is being used. I literally did not, because I did the radial one just literally almost this weekend, so I did not even implement that one in the package, but it will be the next thing to implement. The package is using like the same technologies here, or whatever we have seen today, color blending and save layer here and there, to create like these edgy really cool blending modes. But that's all I have to say on my side.
Cool. Definitely a different use case for the word edgy. Normally it means something a lot less fun than
I
this.
mean, I thought you got it.
Nice. Okay. Well, folks, this has been a super fun episode. We're going to be continuing with regularly scheduled episodes moving forward. My summer and fall of nonstop travel have wrapped up, so Observable Flutter should be more regular for the rest of the year. Raouf, thanks so much for joining. And folks, I'll see you all on the next episode.
Bye. Thank you.